Okay, I'm going to chalk this one up to order matters. So let me give you an example that's similar to the one we actually want to solve, which is that 3 squared plus 4 squared is 5 squared. You all know this, right?
Yeah.
Because 9 plus 16 is 25. But you cannot willy-nilly drop all the 2's, right? Like you can't just unsquare everything because 7 isn't 5. You guys on board with this? If you're gonna try to solve for one of these, right, by square rooting, you need to square root all of both sides. You guys with me on that?
Not each individual piece.
Yeah, not each individual piece. And so when we were asking for log of what, w squared minus 4 minus log of w minus 2
Equals ln 4.
is natural log of 4. Okay, so we wanted to solve this. So you all know that we should hit this with an e to the stuff, right?
Yeah, but not yet.
Okay, so the problem with hitting it all with an e to the stuff is that you have to hit all of both sides with an e to the stuff, right? So if you do that, you will get e to all of this side is e to all of that side.
Yes.
So you e to the log 4 on that side, fine. Easy peasy, that's 4. On this side, however, you have e to natural log of w squared minus 4 minus log of w minus 2. And you would like to say that e's and the logs slash e out, right? That they're unfunctions, they undo one another. But you cannot get at these because of the minus sign in the middle. Yeah, but thankfully we have log rules to stick those together. Or we have exponent rules to break them apart here. I don't care which one you do, they'll both work. You guys recall log rules enough?
Yeah, that's division.
Yeah, this is the division log rule. So I'm going to trust you can do it that way. I'll show you the other way just because kicks. Right? So the other way is use an exponent rule, right? You have e to something minus e to something else.
Which is e to the first thing divided by.
So that's, yeah, e to the first thing. So e to the log of w squared minus 4 over e to the log of w minus 2. And this is supposed to be 4 then. You guys with me on this?
And then you get some.
Yeah, and then the e's and the logs can now reach one another. Right, now I'm doing a function and then immediately following it with the inverse. So I can slash those. So I'll get, I don't know what I'm writing here, unfunctions or something. So I get w squared minus 4 over w minus 2 equals 4. And then what do you do? Nice, the top is difference of squares. So you get w plus 2 times w minus 2 over w minus 2 equals 4. And
The minus 2 is cancel out.
minus 2's are a onesie, right? Slash that guy out of there. So you got w plus 2 is 4. That was a onesie. Then one.
W equals 2.
Okay, subtract 2. So you get w is 2. Yes? You got that.
Yeah.
Yes!
I did too, which is still
I
was
totally
there was
wrong.
8 points.
Yeah, so you can do it with log rules too. Totally fine. You'll get the same thing in the end. However, some of you lost 2 points here because you did not take this, trot it all the way back to the beginning, plug it in. Because if you plug it back in, you get log of 0. Right?
I tried to plug it back in, but it wasn't working, so I just slashed it out. I already did all the equations.
Yeah, so if you go trot this back to the beginning, you'll get log of 0, which is undefined. So you have undefined minus undefined is something. Sure, yeah, I mean, undefined minus undefined can be wherever the hell you want it to be. It's undefined. You guys cool with that? So this thing we should cross out, and what should we actually write as an answer?
Undefined. No solution.
Yeah, no solution or undefined doesn't work. Specifically, no solution is interesting here. That means you can't do this. Right? But what if you did? No, I mean that this thing over here is never that thing over there. So if this is your this is how much profit we're gonna make, you can't hit that. It's not possible. It's actually interesting to know when things are not possible, right? A real life for instance of this is there's a Kickstarter for a water bottle that has a little solar panel on the holder, and it powers a dehumidifier that collects moisture out of the air and fills the water bottle. Right? Epic, cool idea. Self-filling water bottle. Totally badass. Totally doesn't work. It can't. The laws of thermodynamics tell you that to get water out of air, you need a certain amount of energy. That solar panel cannot provide that amount of energy, period. So this kind of thing is something you should do before you try to, well, or maybe it isn't. Maybe the point of Kickstarter isn't to actually pitch products that are possible. Maybe it's just to collect money, I don't know. There are people, Kickstarter actually hired a person. The job description was awesome because they wanted somebody who had a degree in math or statistics, so like master's or PhD in math or statistics, and also master's or PhD in either physics or engineering. And all that person's job was going to be was to look through Kickstarter proposals and determine which ones were physically possible and ixnay the rest. Like, so their job is just to go through and rubber stamp, like, yep, that's physically possible. This is not disobeying the laws of physics. Yes, go for it. Try to raise money. Like, whether it's cost effective or not was not even the consideration. Just, does this obey the laws of physics? Like, can you make this object actually work? So that's this thing, right? They set up an equation, they set it equal to something, they solve. If they get no solution, they put that project on the chopper and pitch it. If they get solution, doesn't matter what the hell it is, right? You just, yeah, sure, go for it. Have fun. Cool. So proposals to cut the planet in half, they do have an amount of energy that you can spend, right? So yeah, sure, continue. Good luck, raise some money.